Welcome to the Physics channel. In this lesson, we are going to investigate upthrust. Suppose you are given the following apparatus: several stones, a measuring cylinder, a top and balance, spring balance, piece of thread, beaker, and a displacement can. And then you are required to carry out the following activities. To start with, what physical quantities about the stone can be measured using this apparatus? So I want you to list these physical quantities about the stone that you can measure using this apparatus. And then give me the procedure that you would use to arrive or to measure these physical quantities. So just pause the video and list down the number of physical quantities that you can measure using those apparatus. Okay, welcome back. Let's look at the number of activities, the type of activities or the physical quantities which you can measure using these apparatus. One of these would be you can use the beam balance or the top and balance to measure the mass of the stone. You can use the measuring cylinder to find the volume of the stone. You're familiar with this procedure where you fill the measuring cylinder with some water and then you immerse an irregularly shaped object in the water. The water will obviously rise. We say the water has been displaced. You take the new volume and then the difference between the two volumes, between the two readings of water in the cylinder will give you the volume of the object. So you can definitely use the measuring cylinder to find the volume of the stone. If the stone was too large and it could not fit in the measuring cylinder, you could use the displacement can. Again, you fill the displacement can all the way with water, all the way to the spout, and then put the measuring cylinder below the spout. Then when you immerse the stone in the water, there will be some water which will overflow into the measuring cylinder. The volume of that water will be equal to the volume of the stone which you immersed in the water. So there are two methods. So don't stick to one method where you only use the measuring cylinder. There is also the one of the displacement can. You could use the spring balance to measure the weight of the stone in air. All you need to do is just suspend the stone using the piece of thread on the measuring cylinder, on the spring balance, and you will find the weight of the stone in air. The next one is that you could even find how much weight the stone appears to have if it is immersed in water. We know that when objects are immersed in a liquid or in a fluid, they appear to weigh less. So you could determine this weight that the stone appears to have. And then the difference between the two, the weight in air and the weight of the object in water, will give you the upthrust on the stone due to the water. In other words, the amount of force that the water exerts on the stone upwards can be measured that way. And then you could also determine the weight of the water displaced. You remember we have just talked about a situation where you trap the water which is displaced in the measuring cylinder. Now, how do you do this? You'll have to find the weight of the measuring cylinder. You'll have to determine the mass of the measuring cylinder when it's empty and when it has the displaced water. The difference will give you the mass of the water displaced. How about the volume of that water displaced? Very easy. It will be equal to the volume of the stone. And of course, you could determine the density of the stone because you've got two physical quantities that allow you to calculate density. What is this formula that you use to calculate density? It is obviously mass over volume. When you look at the information which you have there, you obviously have the mass of the stone and you've got the volume of the stone. Mass of the stone and volume of the stone. When you combine the two, you divide the mass of the stone by the volume of the stone, you will get the density of the stone. So you can see, given several apparatus, you can come up with the type of physical quantities to determine, and we have outlined the method that you use to do this. Now let's go to the second activity. In this second activity, I want you to design an activity to investigate the relationship between the upthrust on the stone and the weight of the water displaced when the stone is immersed in water. In our previous activity, we saw how we could determine the upthrust on the stone and how we could determine the weight of the water displaced. This time, I want you to repeat it several times. Remember, you've got several stones. So for each one of them, measure the upthrust and measure the weight of the water which it displaces. Then compare those two. You can even repeat this investigation using paraffin instead of water. So just pause the video and carry out that experiment. Okay, welcome back. From your finding, you will find this. This is what you will observe. The upthrust on the stone will be equal to the weight of the water displaced. The upthrust on the stone will be equal to the weight of the water or the paraffin displaced, depending on what type of liquid you are using. This is what I wanted you to arrive at, because it leads us to a principle which we refer to as Archimedes' principle. The Archimedes' principle states that when an object is wholly or partially immersed in a fluid, it experiences an upward force, which is of course called upthrust, which is equal to the weight of the fluid displaced. Very important. I will repeat that because it is very, very important. Let's look at this statement of Archimedes. It applies to when an object is completely or partially immersed. It does not only apply when the object is wholly immersed. It applies whether the object is wholly or partially immersed in a fluid. A fluid is either a liquid or a gas. Remember that. It applies to either liquids or gases, and we refer to these as fluids. So this upward force, which is experienced by the immersed object, will be equal to the weight of the fluid displaced. Here you have to be careful. It is not the mass of the fluid displaced, but the weight of the fluid displaced. It's not also equal to the volume of the fluid displaced. It's equal to the weight of the fluid displaced. So this Archimedes' principle must be stated as it is. Do not change any wording of this particular principle. When an object is wholly or partially immersed in a fluid, it experiences an upward force which is equal to the weight of the fluid displaced. So in our next lesson, we are going to look at a question or a problem which is involving Archimedes' principle.